do this.
All right, welcome everybody. Hopefully you can hear me loud and clear on the live stream. If you hear me, go ahead and tap something into the comments so I know. I'm monitoring things to make sure that they're smooth across all the channels. We are live streaming right now on YouTube, on Facebook, on Periscope, and of course on LinkedIn. So it is such a pleasure and honor to be able to join you on this Thursday evening. If you notice that I've been live streaming a little more regularly recently, that's because I have been, and just trying to work on delivering more quality content out there for you all to enjoy, things that are designed to help you in your career and in your interview preparation. It's something that I'm passionate about. It's something that I truly believe in. And so I just love that I have the opportunity to share with the community and with all of you some things that I've learned and helpful tips and whatnot. So that's where we are. I am so excited today to have a special guest with me. This individual I met, he's a colleague, coworker, and it's just ever since I've had the chance to know him, I've just been very excited anytime that we get to correspond. And we were talking, he actually attended the last live stream I did, and he was just like, yeah, you know, if you ever need any help, let me know. And I was like, I think I got just the thing for you. So I'm so glad to have Aaron Vaage on the, actually, you know, Aaron, did I mispronounce your name? Let me go ahead and bring you in here.
Oh, did you ever mispronounce my name?
I just call you Aaron. Okay, so how do I pronounce your last name?
So my last name is pronounced Vaage.
Vaage, yes.
I'd like to tell you, don't feel too bad, because my friend Andrew of I have no clue how many years only found out, I think it was 2 nights ago, how to pronounce my last name.
There it is. There it is. All right. Yeah, so I meant to ask you before in all the planning and preparation, I totally forgot. And so then I was like, all right, well, I guess I got to dive into this. So thank you so much, Aaron, for joining and for participating in what will be a very exciting session as we talk about brainstorming. And so I look a little laggy from where I'm sitting. I don't know what that's all about. And it may not get any better, but that's just going to be the reality of what we're dealing with today. So if you do notice technical issues, just listen to the sound of my voice. Let that lead and guide you. And I expect that we're going to be able to have quite a bit of great discussion again as we just go over you know, how to brainstorm in technical interviews. Again, we're talking specifically about technical interviews today, although brainstorming does extend to a number of different things, not just what you do in an interview. Anytime that you're dealing with a problem and trying to work through towards a solution, brainstorming is an important part of that step. So, you know, it's good to think about how you brainstorm and to improve and practice that. And that's really the goal of our session here today. Okay. So Aaron, you know, I could go through and talk about your pedigree as an engineer and the great work that you've done and all that stuff. But I feel like it's better to introduce you by just showing you this picture. Just give me a moment to pull it up, because I think it's okay. Very telling. Let me, you know, I've been using a MacBook forever. I'm not a MacBook, Chromebook forever. I should know how to do this. Okay, here it is. Here's the picture. Can you tell everybody in the audience about this picture?
Well, I'd like to introduce you to Beardy McBeardface, yes. Who came into existence at a Google Student Summit a couple years ago, I believe.
Yep.
Where all the Googlers who were there were put on one team. There was only, I think, 4 of us. Our names or signatures are somewhere on there.
Right.
And we were asked to come up with a mascot. And of course, the one unifying theme we have had was we all had a deep, resounding appreciation for good facial hair.
That's right. Yep, that's absolutely right. And so it was crazy because we were just like, yeah, let's have the beard, and then, you know, let's have the beard have a beard, and then zap I think there's binary that we had zapping out.
Yeah, it was binary.
Yeah, because, you know, you got to make a digital, and the top hat was I think the top hat was your idea, if I'm not mistaken.
I think I wanted this image to have at least some form of class to it.
Right.
Which means you just add a top hat.
Right. Yeah, so it's classy, like in that office style of classy.
Yes.
Yeah, that's pretty neat. So so there's also something else too. We talked about the fact that you race motorcycles. I have that correct?
Yes.
Okay, cool.
Yes.
All right. So where do you race? You know, how good are you?
This image sums it up probably, as in I really don't know.
Right.
I would like to point out this was after the race was over and we were coming into the paddock. But no, I would not call myself an accomplished racer in any form or shape of the word.
Okay, so you're not quitting your job anytime soon to go do this professionally?
No, considering that in this shot here, we're the last two people in terms of position, and we're still trying to fight it out.
See, you didn't even have to say that. You could have just said that you were, neck and neck for first place. And
first, when you sort in reverse.
I see. Okay, gotcha. Wow. And then, okay, so now we've got this fun little graphic here. Tell us what's happening with all of this.
So this was my first race of last season, fourth lap, right before entering the front straight. This is why I have to say the question as to whether or not I'm any good at my hobbies. I am hopefully better at my day job.
Right. Gotcha. Yeah, I mean, that's pretty impressive. And, one of the things that I love about working in tech is just all the different kinds of people that I get to meet and run into, who are doing a wide variety of things. I work with a semi-pro volleyball player, work with a professional Japanese swordsman and sword instructor, just all kinds of things. And it's just delightful to be able to meet the people that I get to meet in tech. So, if you're used to seeing or thinking about the traditional tech stereotype, it just really doesn't hold up as well as it used to, at least not in my mind, because of all the people that I've gotten the chance to meet. So thank you so much, Aaron, for joining me for this. And I'm going to try to, so the experiment that I was running with the whole camera setup just does not work. So I'm just going to switch between us as we have opportunity.
Okay.
Ooh. Yeah, you kind of, okay, I see what's going on. We'll just work through that little by little. So on to the topic at hand. We want to talk about brainstorming. And I mentioned just a little bit ago about why brainstorming is important. For those of you that know me and have watched previous live streams, I've talked a lot about the problem-solving process that I usually recommend to people that I coach and to the clients that I serve doing interview coaching professionally. And, the thing that's, I think, really key to know is that of all the steps that I recommend, so I talk about repeating when you're in an interview situation, repeat the question. I talk about asking good questions as a follow-up and clarifying the things that are there. I talk about using a practical example where you define your inputs and your corresponding outputs, and take notes throughout this whole process. And then once you've done that, you can then move on to the brainstorming step. And I always say that the data structures, algorithms, the understanding of Big O, that's all the most useful in the brainstorming step. Once you've done the brainstorming, then you move on to actually implementing it, right? So if you're in a coding interview, you're going to use code. And if you're in another kind of interview, you'll use whatever implementation tools are necessary for that process. And then actually test and verify, right? So if you came up with the example input and output in step 3, you can use that in step 6. So this is the problem solving process, which hopefully by now to all of you is an old thing. So, but as I said before, brainstorming is the most important part of that, because this is where you identify the solutions and where you want to go. That sets you up for being able to actually write the code you need to write and make all that happen. So, I think that there are, and, Aaron, feel free to jump in on these things as you hear it. But, I think that there are some essential basic elements that are important for brainstorming. The first thing is research. you need to do your research. You need to gather requirements. You need to understand the problem that you're trying to solve, which is why in the problem solving process, really the first 3 steps of that process, repeating the question, asking follow-up questions, coming up with an example, are all about the requirements gathering. Because if you don't know what problem you're trying to solve, you're going to solve the wrong problem, or you're not going to know how to move forward at all because you're not clear about what your possibilities are. So that's the first thing is make sure that you define your requirements well and that you have understanding with your interviewer or with whomever you are engaging in the problem solving process with. So research is good, but you also need tools, right? So you need the data structures, you need the algorithms. If you're interviewing at top tech companies, this is most likely what you're going to use as the tools. You may not be doing coding interviews at top companies. You may be doing a programming based project where you are doing this away, or you're doing this offline and then submitting a result. So your tools may be frameworks or an IDE or some particular programming language. Those may be your tools. Whatever they are, you need to know them and you need to be competent in those tools so that you can use them in the right situation once you know the problem that you're trying to solve. Third thing that you need to do is know how to measure any potential solution, right? So in coding, in technical coding interviews, we generally talk about big O. So you pick a solution, you pick a solution and you figure out, okay, how efficient is the solution from a time complexity and from a space complexity? So we talk about big O. And big O is expressed as, in the worst case, how fast is this algorithm going to run with respect to its input or in relation to its input? And the same thing for space complexity, right? How much space does this algorithm need to take up in relation to its given input? And you'll use that to measure whether one solution is better than another. So if you have a solution that is big O of n squared, then you know that a solution that is big O of n is better than a solution that's big O of n squared. And so as you're brainstorming, you're thinking of and as you're thinking of the tools, you're going to measure the effectiveness of one versus the other so that you can understand where you need to apply your effort. And then
something that you mentioned there,
yeah, absolutely,
that I think is important to bring up. The concept of measuring is only meaningful if you're comparing.
Right.
Too often, candidates like to seem to go like, well, this one is n squared, but you know what? I really want it to be n. Mm-hmm. Well, the problem might actually not be solvable in n. It's only solvable in n squared. Right. You could do n to the n if you'd like, but measuring is only meaningful when you're comparing 2 different solutions or ideas in this case.
Right, absolutely. And one of the things that I talk about in the brainstorming step is don't just stop at what the naive brute force solution, which most folks are going to come to as they're preparing and studying. You're going to come to a brute force solution. It's going to look like it solves the problem, and hopefully it does. But you want to stop and think of 1 or 2 other ways that you can solve that problem. And one of the ways that you can figure out what direction you can go is by knowing Big O and knowing the kinds of tools and tricks that you can use to get there. So we'll talk a little bit about that as we hopefully jump into some problems and think about that. The last thing that I'll say is pattern recognition is also a very important skill. Sometimes it's just about encountering enough of the right mix of problems that you can recognize how similar one problem is to another one. And so, if you've done a lot of problems relating to array manipulation, then you know the patterns and practices that you tend to use for that. Or if you're using linked lists, for instance, one of the popular patterns is to use multiple pointers. And so, using different pointers running at different speeds can help you do things like loop detection and things of that nature. So as you're practicing different kinds of problems that are related, you start to learn about the patterns there. So when you encounter a new problem that bears some resemblance to ones that you worked on in the past, that can help you make your brainstorming more efficient. Any thoughts on that, Aaron?
Yeah, so with the pattern recognition, I think the most valuable thing about that a lot of people overlook is it allows you to actually think in more macro level chunks rather than those fine little details. It's a lot nicer if you ever build with Lego, for example. you often build chunks at a time and then you assemble chunks. Right. That's kind of the same idea when you solve problems is you want to break the problem apart, but also being able to think in these reusable high-level parts. It just allows you to spend less time worrying about the details. Right. And normally you'll have those efficiencies and measurements already for those chunks ready to go. You don't have to spend time trying to figure it out.
Absolutely. Absolutely. So yeah, I mean, that is, I think you're absolutely right. And that's one of the things too, is I think one of the important aspects of problem solving is being able to take a big problem and break it down into those more manageable steps. So that you can then, and sometimes in brainstorm, you just need to do that. Okay, the problem is too big and nebulous for me to solve. That could mean that I just need to ask more questions, but maybe that also means I need to deal with one specific part and brainstorm that. And then as I figure that out, perhaps that gives me more insight to do the other things. So yeah, I think that sounds great. So here's, I think there's another way that we can also describe problem solving, and we'll talk a little bit about an article that Aaron was so gracious to find and locate. But problem framing, and I can't remember what the other part of that was. You remember, Aaron?
I don't remember the terms they were using.
I can't remember myself, but I think it's solution selection is the idea. So there's problem framing, and then there's solution selection. That solution selection isn't quite it, but you get the idea. The idea is essentially that you're going to, once you know how to frame the problem, you're framing it in a way that makes it obvious what the solution might be, right?
So, of course, having a computer in front of me, I can cheat.
Yes, you can.
It was framing and then algorithm choice.
There it is. Yeah. I knew that solution selection was a little too smooth on the tongue and hard to say. So
yeah. Much nicer.
That's a lot better. Yeah. So that's essentially what happens in the brain. Now, I'm curious, Aaron. The brainstorming approach that I've described is the approach that I like to use and the one that I'm familiar with. Do you have a brainstorming approach that you like to take, or some tips that you like to bring? Why don't you tell us about that?
So I take a slightly more what I would consider an iterative approach, where I don't like having necessarily steps that I work through. I usually jump back and forth a lot, but the key points within it is asking the question of, what does this remind me of? Why does it remind me about that? And how can I use that to my advantage? So often if I see a problem and it says, like, the concept of duplicates pop up, the first thing that should pop in my mind is, sets are wonderful when it comes to duplicates. Right. Removing duplicates, noticing duplicates, that could be really useful. Can I apply that here? I don't need to know how yet. It's usually just can I? And doing that enough times to come up with like that short list of tools that I want to apply to a problem. And then asking, how do these play together? And does that give me anything? And kind of just taking it, that slow approach is just saying, how can I get one step closer to something without having to really dive down one route? Right. I find if I try to do a very strict approach, I get like target fixation on, I want this to work. Yeah. And it's rarely that.
Right. Right. Yeah. That's target fixation is, I think, an interesting word for something that maybe I would call analysis paralysis, where you just sort of get stuck in that pigeonhole that you make for yourself. Like, okay, well, I've been spending so much time on this one approach. How do I, get back out, and should I even bail out, or should I just keep going? And oh my gosh, what time is it? Right. In a 45-minute interview, this is a stressful thing to do. And I think that you're right. There is this tension that happens, right, as you're getting down to that short list, where you want to spend time exploring your options, but not too long that it then becomes impractical for you to move forward on any one and make that happen. But, doing interviews over the years, I've seen a number of people who have unfortunately boxed themselves into a corner, or painted themselves into a corner, as it were. And they just get so insistent on following this one approach, and they can't figure out how to do anything else. And it's something that I do as well, right? It's something that happens not just in interviews, but also professionally. So I totally get that. Cool. Yeah. One of the things that that I want to do is just talk about how to tie these things together. Oh, I'm showing me again. That's not good. Well, you see what's going on. As usual, I have my trusty Chromebook here. Y'all know how I feel about my Chromebook. I love the thing. I wish more people would use Chromebooks, but that's just because I believe that. And by the way, I forgot to mention this earlier, but you know how you know the game. These are just our opinions, right? We're in no way expressing anything official or speaking on behalf of our employers or anything of that nature. It's not about that. We're just sharing tips and information that we think is helpful. I think I heard you agree, right, Aaron?
All right. Yes, most definitely.
All right, well, let it be known. Don't be trying to get us in trouble. So I brought up bigocheatsheet.com, and if you haven't checked out bigocheatsheet.com, you really should, especially if you're getting ready for those coding interviews at top tech companies, because it's such a handy resource, and I think it serves sort of as a map for your preparation, not just for technical interviews, but for growing in the skill of brainstorming. And I came up with a way of thinking about Big O and data structures and algorithms. And I just want to share that with you real quick. So here, one of the things that I recommend to my candidates is, look, you really should know these most common values of Big O. Okay. I tell people all the time, like, if you're estimating something in Big O and you're like, oh, this is Big O of n squared times 5 to the square root of 6, whatever, you're doing it completely wrong. Right. More often than not, when you are estimating Big O, you're going to fall within these discrete values of, maybe O of 2 to the n, or something that's quadratic, or n log n, linear time, so forth and so on. So if you know that up front, what you can do is sort of take a snapshot of this chart in your mind, and what it gives you is a way to figure out how to plot your course. Okay, so there's two things that I use this chart for. So number one, if I know that, for instance, I've come up with a Big O of n squared or a quadratic time algorithm, well, my goal should be to move down to n log n if I can, to linear time, Big O of log n, or Big O of 1, or which is constant time. So that's my goal. So if I'm here, then I know that I want to get down here. If I come up with a solution that's Big O of 2 to the n, or n factorial, God forbid, then I know that I'm headed in the wrong direction, right? And I can't tell you how many times I've seen candidates who, their first solution is linear time, and then they say, oh, well, if I do this, if I just add this to it, then it'll decrease the effort. And I'm like, yeah, you went from Big O of n to Big O of n log n. Is that better or is that worse? And some candidates will say, oh, I think that's better. And it already exposes a flaw in the thinking for that candidate in terms of how they're understanding Big O. And usually I can infer from that, you're going to have a rough time ahead. So knowing these values of Big O and where they stand in relation to each other helps me to figure out what direction I need to go. And I'm always headed towards the left, right? I'm always headed towards one of these values down here if I can, and that's, as you can see, it's color coded. Green for good, right? And dark green for excellent. So that's handy. But there's a second thing that I want to do when I'm brainstorming. And I think there's one really important question that you want to answer during the brainstorming step. And the question is this: what is the best that I can do? Okay. What is the best that I can do? So if I'm looking at a problem, I want to ask myself, what's the best that I can do in this situation? Right. So, if I'm sorting an array, for instance, right? And maybe I can ask you this, Aaron, if you don't mind, but if I'm sorting an array, typically what's the best I can do from a Big O perspective?
Oh, you're not really going to do better than n log n.
Right? Most times you're not going to do better than n log n, right? You're correct about that. Most times it's going to be Big O of n log n. And, if you actually go down to the sorting algorithms here, you'll see that indeed the better algorithms are Big O of n log n. You do have some that are Big O of n times k, or Big O of n plus k. I assume that k represents some random value. So you might be able to do better there, but generally speaking, you're looking at Big O of n log n. I know that I can't do any better than big O of n. Okay, and why do I absolutely know that I can't do any better than big O of n? Well, I know that because I've got to look at everything at least once, right? I can't sort n-1 elements and then trust that I'm done, right? I've got to know what that nth element is so that I can put it in its proper place. Okay, so by knowing the answer to the question, what's the best I can do? If I come up with an algorithm that's big O of n squared, right? I know that anything that if I get something that's big O of n log n, that's good. If I get something that's big O of n, that's good. I probably can stop at that point. Okay, I probably can stop. And there may be cases where that changes depending upon what the problem requirements are. But again, you want to ask yourself what's the best that you can do. Any thoughts on that, Aaron?
A couple. One is, as always, I feel it's always important to understand why your solution is getting that level of complexity. Right. Your solution is going to be, the big O of your solution will be based on the worst component of it.
Right.
Being able to look at your solution and see like, oh, this is why it's n squared. That is their starting point A to get to maybe n log n if you can.
Right.
But at the same time, if you see that part and you realize I can never get better, then trying to get further, like as you said, it's not worth it. But you have to be able to break your problem apart and see that.
Right.
Something else I'd like to point out is, in a way, what's the best you can do is understanding the concept of like diminishing returns.
Right.
If you start off at 2 to the n, and you get down to n squared, maybe that took you 10 minutes. You have 35 minutes left. You still have to write code. Is it really worth trying to get down to n log n? Well, you just already took a huge performance improvement,
right,
going from your 2 to the n down to n squared. It might be good enough for you to continue at that point.
Right, absolutely. One of the things that I've said, or that I've talked to candidates about, is one of the great things about brainstorming is that if you do it right, and if you have a good grasp of the tools and you have a good grasp of Big O, what you can do is speak to the existence of optimal solutions. You may only end up coding the brute force solution, and that may be fine because at least you're showing me that you can code. But then, as we talk to the optimal solution, I can understand how you're thinking about the problem. And because I already know that you can code because you coded the brute force solution, I know that that if you can identify the optimal solution and explain it clearly, that you would be able to take those thoughts and turn it into meaningful code. And so, I speak about it as one of those things that can help you win the day early, even if you don't get finished all the way with writing out that last curly brace of the optimal solution. So and that's the thing, is that in an interviewing situation, you only have so much time, right? You've only got an hour or 45 minutes, or hopefully not less than 30 if you're going to have a meaningful discussion. But that's it's very time boxed, and so you need to work well within that time, right, to show as much good as you can within the time constraints, so that you're leaving your best impression. And that's really what it's all about. Okay. One thing that I'll say real quick is another technique that you want to try when you're brainstorming is, okay, so now you know where you want to go, right? So let's say that we're looking at a sort and we know that it's going to be big O of n squared. Okay, well, now I want to get to big O of n log n. How am I going to get there? One of the keys that you want to use is, again, understanding the big O of your common data structures and sorting algorithms, right? And so, for instance, if we're, one of the things I'm big O of n squared, what will get me to big O of n log n? Well, I know that merge sort could work. I know that heap sort could work. Tim sort, I'm not even familiar with that one. I don't even know how that, was this on the list? I don't remember. But Tim sort, right? There's also cube sort, of which I'm not really familiar, but I can see the smorgasbord of options that I have available because I've done the work to study and get familiar with those data structures. Now, Aaron, when you're preparing for technical interviews, and maybe you can tell me about what you did in your technical interview, but how much did you memorize algorithms and data structures? Because I think that's maybe something that folks get confused about in terms of, how much they should spend time memorizing in an interview. What are your thoughts on that?
I am slightly a bad example of preparing for technical interviews. My preparation for my Google interview was I bought cracking the coding interview. I skipped 3 pages and then I put it away.
Okay, got it.
But in terms of memorizing things, it's like you said about the tools. It's about knowing your tools, knowing when and how you can use them. Before my Google interview, I was very familiar with how I'm going to use maps, how I'm going to use lists, when I'm going to choose a linked list over an array list, when I'm going to likely want to sort data, when am I not going to want to sort data, when is a set useful, and just knowing when they are useful to me, not when they're useful to the problem. When am I going to make my life easier by using these data structures? And knowing what the runtimes are for those data structures. I'm not one necessarily say you should memorize algorithms unless there are ones that you're going to use in a adapted form. So a lot of your graph or trees or graphs algorithms are useful to understand. What is a depth first search? What is a breadth first search? Those ones are not implemented anywhere for you. Understanding how sorts are implemented, not useful at all in terms of an interview.
Hey, I think that I second you on that for the most part. I will, however, recommend memorization from this perspective. So, I spent quite a bit of my time preparing for my interview just practicing the language, because I decided that I was going to interview in a language that I don't use every day. And to help me get more practice in writing just in that language, I took some algorithms and data structures that I also needed to study to learn more about why it works the way that it does, and committed those to memory and just typed them out from memory, so that number one, I was getting the coding practice, but then two, I was understanding, what code looks like in those algorithms, so that when I'm crafting my own, I'm pulling from the experience, right, of like doing merge sort from scratch, or implementing a dictionary from scratch, or whatever that may be. And from that perspective, it was very helpful for me to understand like how to set up my loops and variables, how to do basic swaps, how to swap elements in a linked list, or how to swap elements in an array, or do all those kinds of things. So I became a lot more comfortable with that process in writing that code, because I was doing that from memory, using things like merge sort, or doing that from like implementing the code for doing tree rotations or whatever. But I'm totally with you that when we're thinking about and studying data structures and algorithms, it's about understanding their role and their purpose and why and the problem that they're trying to solve, more than understanding how to write those algorithms from memory. Because I don't know about you, but I don't know anyone that's ever had to implement just a straight up algorithm straight from memory, unless they were very junior, maybe.
As a technical interview or at work?
No, I'm just in general, in your experience.
Yes, I had my very first technical interview I ever did as an intern.
Oh, really? Okay, yeah.
The interview question was to implement Stirling.
Okay, gotcha.
Very simple algorithm, but it requires you to understand a lot of details that really you shouldn't have to worry about most of the time.
Right, absolutely. Yeah. So,
but in a way, though, it goes to something that you were mentioning about spending time to really understand how to write in your chosen language. Because what I always get concerned about with candidates is when they have to, in the middle of trying to solve a problem, come up with an idea, they're trying to remember how to write in the language that they chose.
Right.
Like that language should be as comfortable to you as your native speaking language.
Right.
You shouldn't have to be thinking, how do I write a loop right now? How do I write this class? How do I express this idea in this language? Right. You should just be purely thinking about, what is this idea?
Right. Yeah, no, absolutely. And that is, again, one of those things that I tell folks that all the time. Like, if you're having to figure out where to put your semicolons and curly braces in an interview situation, you're already doing it wrong. And one of the things that you can easily do to help yourself out while, like I said, managing two things at the same time, is to memorize just a few of those basic algorithms, just so you have it. And, there's another way in which memorization works against you. I talked about in brainstorming the importance of pattern recognition. I think there's probably some of you out there that, your goal is to do 2,000 leak code questions and 1,000 HackerRate questions, and to memorize the solutions to all of them, with the hopes of being able to, maybe get a question that you've already worked on before, so that you can breeze through that interview process. And that's not going to help you, number one, because typically that's obvious to the person that's interviewing you when you've done that. And two, it's not about memorizing the specific problems. It's about memorizing the kinds of patterns and techniques that you use to solve those problems. And so, if you're out there hunting down thousands of leak code questions, thinking that that's going to do it for you, that's not going to. You really need to spend the time thinking through why a problem is solved the way that it is, thinking about what kind of options make sense. And as you talked about, Aaron, narrowing down your list of choices. So very cool. Very cool. Well, I think that we've talked a bit about the actual technique, and we've talked a little bit about some tools. BigOCheatSheet.com is one that we talked about. We talked about cracking the coding interview. There's also Programming Interviews Exposed, I believe, which are a couple of books that also talk about, how to engage in the problem solving process, what to do when you get stuck, right? So check that out. And then, of course, the sample problems that walk through, the different kinds of techniques and approaches that you can use. So really pay attention to that, to those resources, and to the exposition of, why the problems are solved the way that they are. But don't do that before you really take a critical look for yourself and try to solve it. So, one of the things I say is that when you're doing practice problems, you really want to go until you can't go anymore. And at the point that you feel like you can't go anymore, that's when you stop. Because I think that what you learn in the struggle will help that memorization to stick a bit better. Right. Now, sometimes you're going to be practicing for time and just trying to get down to, like half an hour or whatever. And that's totally cool. But you also need to set aside some time to work on problems where you just, that you're going to struggle and bump your head, but try to do that and really spend time so that you can soak it up. Cool. All right. Aaron, how about we talk about a couple of actual interview questions? This is a first, I think, for me. I know that I've in the past done an interview question sort of live-ish, where I just recorded myself doing it without any preparation and then put the recording up. But I think this time we can talk through a couple of problems. So you can ask me one, I'll get in the hot seat, and then I'll turn around and ask you one, and we can talk about how we were brainstormed through those problems to get through a solution. And then, we can reveal the answer at the end. Ultimately, and for those of you that are watching, feel free to engage in the comments with your thoughts and how you might brainstorm this. Love to see what you all are thinking and how you're going through this. Now, I'm always generally out of practice because it's been a long time since I've had to interview. And Aaron, I don't know when the last time you had to interview is.
Let's just keep making excuses for ourselves so we don't look so bad in the coming minutes.
It's called leveling expectations, man. I'm setting and leveling expectations here. So, but anyway, you've got a problem. Why don't you go ahead and lay it on me, and I'll get into focus mode.
All right. So I'm going to give you a circle in 2D space. Let's call this circle C.
Okay.
And I'm going to give you an integer. We'll call it n. What I'd like you to do is to give me back n uniformly distributed points within C.
Okay. So I've got a circle in 2D space. And then you said that I've got, um, I was busy trying to write that down. Can you repeat that one more time?
Yep. So I'm going to give you the
Yep.
circle.
Mm-hmm.
Okay. I'm also going to give you an integer. We'll call it n.
Okay.
I'd like you to give back to me n uniformly distributed points within that circle.
Back. N uniformly distributed. You said in uniformly distributed points, is it? Okay.
Yes, points.
All right, cool. So I've got a circle in 2D space. You're going to give me a number. This number is going to be an integer, so thanks for that. And then it's going to be, I'm going to have uniformly distributed points within that circle. Okay, so by uniformly distributed, I think I need help understanding what that means. So maybe I can just use an example. So I've got a circle here. Do I need to be concerned about the size of the circle?
Yes.
I assume I would need to be. Okay, so I need to know what the size of the circle is. And I assume that I need to know what the size of the circle is so that I can put the points in here and space them evenly. Is that what it means to be uniformly distributed?
No. So uniformly distributed would mean a uniform random distribution.
Oh, I see. Okay, so the points just need to appear randomly within this circle. Okay, so visually speaking, if I have this circle, then I would, like this would be a random replacement of...
Yeah, if I said 4, that would be
okay,
fine.
n equals 4, and then, okay, so I've got this. All right, cool. So I think that makes sense. And then, okay, so what other questions can I ask about this? How is there any limit to the number of dots that I could be told to put within the circle?
Not really.
Okay.
N is going to be a reasonable size integer within the constraints of your machine.
Okay, reasonable size, and sorry for the chicken scratch, but it's more important that I read it than you, so this is for me.
Yeah.
Okay, so I'm gonna have a reasonable size N, so I don't need to worry about running out of computer memory or anything like that. Okay.
I'm not going to push that level of complexity.
Okay, cool. Is it possible that dots can land in the same place or at the same coordinate, let's say?
Yep, that's allowed.
Okay, that's fine. That's fine. All right, so dots can land in same place. All right. And can I have dots on the border of the circle?
Yes.
Okay. So dots can be...
We'll say... Yeah, on the edge of the circle will count as within the circle for all intents and purposes.
Right, on the edge. All right, that's cool. Is it possible that n will ever be 0? Or a negative number? Will ever...
Negative, no, but 0 is a valid number of points to get back.
All right, I think that makes sense. Okay, so I think I have a firm understanding of the problem right now. Let me just talk through, I think, what the input and output would be. So for the circle, I know that certain languages have a structure for like a drawing or something of that nature. Can you tell me about what, how the information will be? So n is obvious; it'll just be a variable that's an integer type. But the circle, is there a specific way that it's described, or is that left up to me to decide?
You can hold that information however you want, but I will point out that the circle will have an origin and a radius.
Okay, that makes sense. Okay, so in that case, I expect that I'll have, let's just maybe say that I have a circle object. Oh, let me just do that better. So circle, and then for circle, I'll have origin, as you put it, and that will be a coordinate.
Okay.
Which is, a coordinate is just x, y, and then a radius. Okay, cool. I think that makes sense. Okay, so here's kind of what I'm thinking. So I'm going to need some math for this, aren't I?
So in terms of mathematics, you can assume all those functions are provided to you. I'm not too concerned about your ability to remember basic geometry or anything like that.
All right. So here's my thinking. My thinking is that what I would essentially do is for each dot that I need to place, I would start at the origin and I would produce two random numbers. One random number is going to determine how far from the center. So let me just do this. So there's going to be one that determines how far from the center we go. So that's going to be bounded by the radius. So I'm going to take a number between the starting coordinate and the radius. Or sorry, some number between 0 and the radius length. Let me just put it that way. Okay. So that determines how far into the circle I'm going to generate that point. And then I'm going to have another that determines where along the circumference of the circle at that point I want to then place a dot. Okay. Right. So my thinking is like, maybe the first calculation will bring a dot here. And then another calculation will determine like how, let's say maybe I should go clockwise. But how far around clockwise I'll go. And then just continue that n times.
What if I was to tell you that would actually yield a non-uniform distribution?
Oh, because I have to choose two numbers. And okay.
Not so much. Think of it as where would be the most dense part of points within this circle using that method?
Let's see, the most dense part. Oh, it would be wherever I started generating points from the circumference, right?
It would be right near your origin, so you're on the right track here.
Okay.
Because if you think of the resolution of your sweep,
right.
If you were to say increment, for lack of a better, if we took randomness out of this and we did it in even step,
right,
your points on the outer part of the circle will be wider spaced than the ones on the inside.
Yeah, that's right. You're absolutely right about that. Okay. Okay. So that's interesting. So my first thought is go from the center and then choose random around circumference. Okay, cool. So, but it sounds like that is not an ideal approach because it's not going to give me a random distribution. Okay, so
give me
a uniformly random distribution. Okay, so now what I need. So now I need to understand how I can actually do this uniformly. If I'm thinking about the best way for me to do this, it would be great if I had my thinking on this was that it's going to be a linear time solution, right? Where I've got to do some amount of work in times for each of the dots that I need to select. And I don't know if I would be able to do better than that. Maybe I could use some math trick to do that. But I'm thinking I'm going to have to generate at least n random coordinates. So I don't know. Does that make sense? Maybe this is too much of a hint, but do you think I'd be able to come up with a solution better than linear time?
And have it uniform I believe random? Not.
Okay.
If we were to think, as you said, and if we think back to our previous conversation about kind of our limits within a problem,
right? If
we need n points and our points have to be randomly placed,
right?
We need at least n random points.
Right. That's what I'm thinking. Okay. So I know that I need to do some amount of work, and the question is, how am I going to do this uniformly? So let me think about that. So it would be interesting if I knew all the points that I could generate within this circle and then randomly choose from that set.
Okay.
That would be another interesting approach. So let's see, generate all points that could be generated, and then choose in randomly. Okay. So I could go with that approach. That one sounds crazy to me because there could be a lot of points, and if we think in the mathematical sense, that could be well. If I'm looking at integers, then there's only going to be a finite number of points that I could generate. Actually, because we're going by integer increments, and so
when did I ever say we were using integers for the circle?
Oh, okay. So it's not true that the radius is going to be an integer.
No, the
coordinate may not be an integer either.
The radius, they're floats.
Oh, ooh. Okay, yes, that totally makes sense. Okay, so it seems to me like it'd be incredibly impractical to generate all the points and then choose in randomly from that perspective. Yeah, that makes sense.
It'd be very difficult.
Yeah. Okay, so.
But I would also, though, like to point out that idea is pointing you, or an element of that idea is useful to a solution to this problem.
Right. Okay. Interesting. So an element of that solution is pointing me. So is it the idea that I can generate a set of points and then randomly choose n of those points and make that work?
So think of it more at flip where the randomness comes in.
Okay. So if I'm flipping that, then that means I'm choosing n random things and then applying it to my circle in some kind of a way.
Not quite.
Not quite.
So if I gave you a point, could you tell me whether or not it is a useful point?
Yes, because I could determine whether or not it would land in the circle based on the origin and the radius.
Okay.
And so as a result of that, I could just generate points randomly, and if it falls in the circle, keep it. If not, discard it. But it doesn't seem like that would give me uniformly random distribution. But I'm rusty on math, and I was always horrible at math anyway. But that is an approach.
Okay. Yes. So if we were to think of it this way, what if I told you that the world had limited bounds to it, that it could only be, the world was only so wide and so tall? If I was to give you a point within there, right, and I always just chose a random point within there, it would create a uniform distribution across the world.
Okay. Wait, so articulate that one more time, because I'm about to ask you to give me the answer because I'm running out of time. But say that one more time.
All right. Let's say that the world was limited to be a square.
Right.
And if I'm just using a basic random function and I keep doing it for x and y,
right,
I will get uniformly distributed points within that square.
Right. Well, but I would assume that you'd be able to generate random points outside that square too, right?
Not quite. So once again, assumptions here. But
I see. Yeah. Okay, gotcha. I understand now. I think I get you. Okay, cool. So before I move on to this, I think in the interest of time, I should have you reveal what what we were doing, because this is a fun problem.
I like this problem. When I came across it, I'm like, I'd never asked at an interview, but I love this problem.
Yeah.
So what you can do for this is you draw a box around your circle.
Right. So
you create a random point in the box.
Right.
And then you check if that point is in the circle.
Right. Right. And
that will give you a uniform. If you do that until you get n points, you have n uniformly distributed points within the circle.
Right.
The interesting thing about this problem, aside from if you like geometry, it's fun, is how do you evaluate the runtime of this problem?
Right. And for me, it seems like it would be, so I've got to do that at least n times, but there's points that I have to discard too. And so there's for me, I would think it's like big O of n plus k. And I'm trying to think of what the worst case scenario would be here. But it's hard to describe the worst case because I'm not guaranteed to have any particular, like I'm not guaranteed to have to generate only invalid points or only valid points. I'm going to get some combination of both of those things.
So normally what will happen is, so most random functions that you'll ever be given, unless someone is giving you a stats library where you can say, give me a non-uniform distributed or approximate, they're always uniformly distributed.
Right.
Which means
right.
if, on average, you're going to be getting points within that range, which means if, say, since everyone is equally likely, if say I was doing integers and I asked for 10 integers, it shouldn't take me too long after 10 before I start getting all of them.
Right.
Now, there's a horrible case of it keeps giving me like 1.
Right.
Like if you think of rolling a die. So in a case like this, it's still linear time.
Right.
It's just, as you said, there's a bit of a multiplier here.
Right.
Based on the fact of there's a ratio between the circle to the square.
Right.
But once again, this is where understanding big O comes in, as you pointed out earlier, which is, I know that that's a constant. I know it's a multiplier. This is going to reduce down to of n again. So this can still be a linear solution.
Right. Right. Yeah. Okay. That's pretty cool. So I'll ask you this, since I'm in the hot seat, how did I do with my brainstorming and talking through the problem and getting to at least as far as we did for this limited set of time?
So I'm going to say you had blinders on a few points.
Yes.
One is the moment you asked one question, got an answer, you didn't ask the next couple questions to make sure you get the full answer. And I'm thinking of the circle.
Yes.
When I said, it's an origin and a radius, you're like, great, I got an answer for what the circle is. I'm ready to move on.
Right.
And it was like, oh, you had a lingering assumption here. That's going to be an integer because you got your use, I guess, working with drawing libraries that work in integers.
Right.
So there's that point. Another point that I often find that kind of you did as well, but also candidates will do, is they're almost afraid to say like, hey, can you give me a quick lesson on this? I'm not familiar with uniform distributions. Can you give me a 2-minute like briefing on what that means?
Right.
So that I am ready to continue. One of the scariest things, someone will have to say in an interview is, I don't know. Right. And it's oddly enough, one of the most important things for you to say, because it tells the interviewer, I do need to step in. I can provide you with some quick information and move on. Because chances are, that's not the thing I care about.
Right.
I don't care if you know stats, but what I care about is, can you use this odd behavior going forward?
Right. Excellent. Yeah, no, I think that makes a lot of sense. This is a really excellent question. It's one that's hopefully for those of you who were listening and watching me struggle through that you could pick apart some of the things that went well and some of the things that didn't go so well. Ultimately, we didn't have the full 45 minutes to work through. But actually, I can ask you, and how long do you expect that it would take, I think, a reasonably strong candidate to get through a question like this?
I don't. So I'm going to say, I don't know.
Okay.
I think, though, if I was interviewing a student who was, taking college courses, let's say they're probably like a sophomore or something, they've taken a stats class recently. They have seen uniform distributions. They're not too afraid of that. They've probably taken a linear algebra class or a geometry class. The concept of is something in a circle is not going to scare them.
Right.
I think within 45 minutes, this is a fairly reasonable problem. What I would fear with this question is why I wouldn't actually ask this in a real interview is the problem someone sees that something that's not programming.
Right.
Or it's not data structures, it's not algorithm.
Right.
They freeze and they say, I don't know this.
Right.
Or they to themselves say, I don't know this, I'm screwed, rather than just saying like, hey, I don't know this part.
Right.
I can tell you exactly what I don't know. I think though within like the code for this isn't really that hard. Right. Especially if I say, here's a function for this, here's a function for this, here's a function for this, which in an interview I will gladly do.
Right.
For you.
Exactly.
I don't want you to write a point and circle test. It's we've all seen it. It's not what I care about in this interview.
Right. Yeah, absolutely. Yeah, and again, that's one of the other reasons why I like it is because I was sort of thinking in my mind like, okay, how might I solve this if I were, how might I solve this if I were to think about it in terms of a graph problem? Is it really a graph problem? It doesn't really feel like a graph problem, so let me ditch that idea. Is it maybe does it make sense for me to use a map? Not quite yet. It seems like it's premature for that. Let me just figure out something that might work. And then after that point, optimize once I've got something down. And so the reality is that I felt like it was good to come up with a naive solution, even though it didn't completely solve every problem. At least I'm leaning into that and showing that I'm thinking about it and coming up with a solution. And then even with the second point, it was getting me a step as I'm thinking through it again before writing code. And then I think the helpful discussion was helping me to get there. I felt like it was a little more hand-holding that I would have liked for me, to get the input from you. And so I would have preferred not to have had that. But at the end of the day, I want to be able to do well and get to a point where I can code. And so I don't mind asking the questions. And, at one point I asked you like, hey, I'm thinking big O of N. What do you think about that runtime? Do you think that I might be able to do any better than that if you're willing to answer? And I felt like it was useful, and it was good that you actually revealed like, yeah, I'm thinking somewhere around there would be good, because then I know that I don't need to chase something more boutique in terms of solutions. So
yeah, in terms of an interview, if someone was to say like, hey, I don't think I can do better than this because does that sound right? I, as an interviewer, will often say like, yeah, you can't do better. Or no, there's a bit more you can get, but it's not worth your time. Or what I won't do, though, is if someone says, I think the best you can do is N. Or the best I can do is N squared. Is that right? It's like, why do you think that's the best you can do?
Exactly.
You haven't, that's a shot in the dark.
Yes.
Prove to me you've actually consumed this problem, you understand part of it, and you've done a little bit of thinking on this, and I will remove the anxiety that you feel.
Yeah, no, that's really good. Well, so we're at 6:02 according to my clock right now. I was hoping I'd be able to throw a problem at you too, but mine is going to be not nearly as interesting as yours is. So I'm very grateful that we've had the opportunity to do this session. I want to be respectful of folks' time who agreed to be on the live stream. I will quickly point out that there was an interesting article that you found, Aaron, and I want to bring it up here, but where it is another engineer talking about an interview question that they like to ask and how they were assessing that. What did you think about that? How do you think that the folks who are listening can find that to be useful?
I really liked that article, mostly because specifically that writer who will say, no, this one's at Google. This was his problem when he was at Google. He no longer works at Google. That question is no longer asked at Google. But it gives you a real insight into what interviewers are thinking of when they're coming up with problems, what they want to get out of these problems, but also how solving these problems, it's not, you don't have to be, your ideas don't have to be new, they don't have to be grand. It's really just taking an idea from somewhere else and applying it, an old idea to a new problem. And that is a lot of what at least my day-to-day life is. And it's what a lot of interview problems are in general. It's just interview problems are usually a little bit more isolated. And what's nice about this article, at least, and if you go and read through it, is you can see how they walk you through that process of saying like, okay, this is the problem. This is how the problem is designed. This is how the problem breaks down. These are the parts that we don't tell you. These are the parts that asking good questions will give you. And this is how it can lead you to seeing, oh, this relates to that old idea that I learned once before, and how I can reuse it here.
Right. Absolutely. Yeah. So I'm going to link that article at some point once this all gets published out there, and just share that all with you so that you can see and benefit from that. But, Aaron, I want to thank you so much for joining me today. This was a super interesting live stream. And, we were talking about earlier, like, should we do this as a live stream? Should we take that risk? Yeah. And, he was all in for it. And, I think it takes quite a bit of courage to even do that, appearing in front of, all the people watching and checking us out. And, I think it was just great having you interview me and this just be an authentic experience where I'm working through a question that I haven't heard before. Because I want you all to see that, the things that you're doing right now, even though I have the job and have gone through the process, I struggle with these things and I'm still learning how to do these things better as an engineer. And Aaron, I'm sure that the same thing is probably true of you as you're looking at things and assessing things and figuring it out. Having to struggle through the process of evaluating and brainstorming what's the best solution for the job is just something that we do. And, it's a muscle that you continue to develop even after you've gotten the job and have been successful. Yeah. So, Aaron, again, thank you so much for your time. I'm going to let you know, I'm going to tell everybody on the live stream so that they can hold me accountable. I'm going to make sure to send you a mug from my consulting firm, Morgan Latimer Consulting, where I help folks prepare for interviewing and stuff. It also has Garrett A. Morgan and Lewis Latimer on the back. So hopefully you will enjoy that. And I've got some other swag that I'll send you too. I want to thank you so much for spending time with me and for making this one of the most interesting live streams that I've been able to host thus far.
Well, thank you for having me. Hopefully everyone else found it helpful. And of course, if you do enjoy Anthony having guests, let him know. And I'm sure he'll get someone else who's probably more interesting than myself.
I like having the guy that crashes motorcycles, but I know a ballerina that I can talk to with some other folks too. So maybe I'll get them involved. And also, by the way, kudos. I see we didn't even talk about what to wear for this, and you went ahead and got the button-up shirt. I half expected that we were both going to be in t-shirts, and we decided to class it up a bit. So.
Yeah. My general rule is even if you're doing interviews from home, you should still be dressing as if you're going to be doing them in person.
I got you. So no Halloween costumes then?
No.
All right, excellent. Well, again, thank you so much, Aaron. Appreciate your time. And for all of you who attended the live stream, thank you. Again, you can follow Anthony D. Mays on all the different platforms, anthonydmays.com. Sign up for the YouTube channel where more of these sessions will be happening. You can find Aaron Vaage. Did I get it right? All right. Yep. Fantastic. I got Aaron Vaage. You can find him on LinkedIn, so make sure to connect, and I'm sure that he'll be open to answering questions as you have them. With all that, thank you all. Have a wonderful Thursday evening. Peace.
It's tough to know. I think it's one where it has that really strict pivot point between you're either going to get it or you're not. And I don't like that. We're live again, it looks like.